Yeah, hello everyone. Shahid here. This session is about services in Kubernetes. Okay. Before getting into the details of services, right, let's first try to understand why the need of services came up. Okay. So I will take you to the killer coda and I have some of the example prepared here. So I have given the link of these examples also in the description. So what I will do, first I will create some of the pod and I will directly show you the problem, okay, why the need of the services came up. Okay, let's create one of the deployment. Let's create a deployment and name of the deployment is backend. Okay, what actually I'm creating is some kind of communication between a backend microservice and front-end microservice. You can consider it as that example. Okay, so this is the deployment. Okay, the name of the deployment is backend. I will be having a two replicas. Okay, and this deployment will be creating a pod. One of the pod, it will two pods it will create. Okay, and pod and container details, image details, everything I have mentioned here. What I will do, I will create the some of the pods, apply minus f. I have created a backend pods. Okay, get pod minus w. So I have two pods created now. Fine. What I will do, I will create one more pod, and that's a front end pod. Okay, that example also I have given in the link below. One of the front end pod we will create using the deployment front end dot YAML. What this deployment will do, it has a name front end and it has one replica and it will create one sample pod. Okay, get pod minus w. So, sorry, I didn't apply it yet. Apply minus f and front end. With this, you can see total I have two pods running, two set of pods, but one deployment is having two pod and another deployment is having one pod. So we have one front end pod and we have one back end pod. What I want is like I want to show you how a front end pod communicates to the back end pod. Yeah, and before that, if you observe here, what I will do, get pod minus O wide. I will display the pod in a detail. Every pod will have its own IP address. That's how Kubernetes, whenever we create a pod, whenever we restart the pod, whenever a new pod comes up, Kubernetes assign a IP address to each of the pod. Okay. Now we will go inside the pod, inside the front end pod. Okay, so we are inside the pod. What I will do, okay, I will tail the logs of other two backend pods here. We will tail the logs of these backend pods into two terminals, k logs minus f here. So in one terminal, I have tailed one of the backend pod, another terminal I have tailed one of the backend pod, and these backend pods are running on port called 5678. Okay, what I will do now, I will perform curl on this IP, which is one of the backend pod 5678. Okay, I got the response hello from the backend pod. Okay, and this request reached to this backend pod and I got the response. Then let us send a request to this backend pod now. Curl IP address this, and you can see even this pod received a request now. So with this, what it looks like, yeah, we are successfully able to communicate to backend application from the backend pods from the front-end pods. So this looks like, yeah, we can configure these IP addresses in front-end application, and whenever we want to communicate, we will communicate it. Since every pod is having a different IP address, you can have a logic like you can configure multiple IP addresses here and you can communicate when in the production in the live environment. Okay, but the one of the major problem is these pods are ephemeral in nature, means they are created and they are destroyed. So whenever they are created, the IP address of this pod will get changed. What I do, I will delete this pod. I will delete one of the pod. Okay, here get pod, here get pod minus the void. Let me delete one of the pod. Since it's a deployment, pod will be recreated. Okay, I have deleted the pod. So I have deleted a pod ending with Q9R. Q9R pod is gone. A new pod came up ending with 2Q7. But if you see, the IP address got changed. The pod which I have killed, it is having this IP address, and the new pod is having a different IP address, 1.7. So that's how Kubernetes works. Whenever we restart or bring up a new pod, it will have its own new IP address. Now, if we try to communicate to older IP, it will not work. Okay. So this is the problem. If this is the reason why we cannot configure the IP address in the front-end pod application. So to solve this problem, we need something. We need something like DNS or some mechanism that gives fixed way to reach to the pod. Correct? Like even if pod restarts, that should not change. So that feature is called services in Kubernetes. Okay. So what is Kubernetes service? It's a service. Okay, it's a resource. It's one of the resource that provides stable endpoint to one or more pods to facilitate seamless communication between pods and external client. And external client can be pods of the same cluster, pods of the different cluster, or it can be anyone in the world access. Okay, and the service name, right, remains the same even if pod restarted or if we scale it to more pods. So we will see the same problem, how we can solve it using a service. I have a service here, link I have given in the description, service. Okay, you can take this service. Okay, now I will create one service, svc.yaml. Yeah. So what I'm doing, I'm creating a service which will serve the backend application. Okay. And how we, this is, for example, the kind is a service, name of the service is backend service. And how I'm attaching a backend parts to this service by using this selector. Selector is app backend. You might have seen when we have created a backend pod via deployment, we have given a selector here. We have given a label here. The label at the line number 15, we had given the app equal to backend as a label. Same name we have to give in the service as a selector. Then this service will pass or will route all the requests to that particular pod, those pods. Okay. Now, what is the routing logic? Routing logic is the protocol is the TCP. 80 is the port. It is the port where service will be listening on, and target is the port where pods are listening into. So what will happen when we create this service? This service will be accessible across the cluster. Then people will communicate to this service now. Okay, people will communicate to this service, and service will take care of routing the data into pod. Okay, so people will communicate to this service on this port. So this service will forward that request to the other pods which are attached here on this port. Okay, I will show you when I create. Okay, apply, and we have one more parameter called type equal to ClusterIP. There are several types of services which I will be explaining later. So I will create a service now. K apply -f svt.ml. Okay, now K get svc. So you can see I have a service created, and this service will have one IP address. Okay. If I describe this service, I will describe this service, then you will see describe SVC backend service. I will describe. Okay. Describe SVC. I will describe the backend service. It will tell which all pods it is serving into. So name of the service is this service, namespace this, label we have not given, type is the cluster IP, annotation is backend, fine. The IP address of this service is this, and you can see the target port is 5678 and port of the service 80. Okay. And the endpoint section, if you look into the endpoint section, which will tell which will have the list of the all the port this service is serving into. Okay, so whenever someone communicates to this service, it will forward the data to this pod and this pod in a round robin fashion. Okay, and what are these pods? These are actually backend pods. Okay, k get pod minus o wide. You can see the IP address of 15 first backend pod, 17 is the another backend pod. Okay, and if you delete, let's say you delete the pod, that I will show you while explaining the demos, while demoing it. Now, how we communicate to the pods? We don't use the IP address of the pod. Now we use service name. Okay, backend service, and the port is 80. Okay, port is 80. Let me tell the logs also. This pod is no more present. Let me tell the log of other pod also. Okay, so what I will do, I will send a data to service now 80. He got the response. The request went to this pod. Okay, now I will send one more request. Some refresh. I will do curl 80. Now you can see request came to this pod. Okay, I will run few services like few curl request. I will send few more. For example, curl backend service, backend service, backend service, backend service. Now you can see traffic is being distributed. Some requests came here, some requests came here. And even if I restart the pod now, k get pod minus o wide, k, I will delete the pod. I will delete this pod. Okay, I will delete this pod, which is having IP address 1.5. Now you see I got new IP. Okay, and if I describe the pod, previously it was having, you might have seen previously it was having the previous pod IPs. Now you see the new pod IP is 1.8 and 1.8 got attached here. If I delete this pod, whatever the new IP it gets, and that will get attached here. Now if we run curl request, the request will start coming to this pod. Now you will be seeing that this pod is started receiving the request. Nowhere we have configured the IP addresses. So what we have configured? So if you configure the service name at the front-end application, whatever pod gets restarted, scaled, whatever, it doesn't matter. It always the service will take care of updating the IP addresses in it, and it take care of routing the message to the pods in round robin fashion. So that's about these services. Now we have several types of services. ClusterIP service, NodePort service, load balancer service, external name service, and headless service. So whatever we have created is a ClusterIP service, but in going forward, right, we will understand detail about these types of services. So thank you, but now let's continue with types of services. Let us now try understanding what is ClusterIP service. Okay, ClusterIP service is a type of service that assigns a virtual IP address to the service, and we map the associated pods to those services. Okay, those service. Okay, and this will enable a communication between the pods within the cluster. And in our this service chapter, we use this name within the cluster and outside the cluster several times. So it is better to understand what do we mean by within the cluster. If you look into this diagram, this is the typical infrastructure of Kubernetes. Okay, this is the typical infrastructure of Kubernetes where we have master nodes where we have several worker nodes, and each of the worker nodes is hosting several apps. So these pods of worker node 1 may communicate to the pods of worker node 2. Pods of worker node 2 may communicate to the pods of worker node 3. Pods of worker node 1 may communicate to the pods of the deployed in the same worker node, and these worker nodes also may communicate to the pods. So whatever the communication is happening within this cluster, right? This we call as a communication within the cluster. Okay. And let's say if someone wants to communicate to these pods from the internet, let's say someone wants to communicate to our services from the internet or from any other machine, that communication, what we call it as a communication from the outside the cluster. Okay, this is the difference between what is within the cluster communication and what is the outside cluster communication. Now we will look into the demo. We will create a service now. We have already seen in our previous example also that how to create a service and few samples. I will create one application called as backend application, and if we look into the deployment file of this backend application, what we have is we create the two replicas, and we give the label for this pod as app equal to app colon backend. Okay, so we give this label, and this same label we will be using while creating the service. That's how service will identify which pods they wants to point, and this pod will be listening on port 5678. Okay, so we will create this pod k apply -f backend. So you can see we have two pods here, -o white, and both the pods, okay, and okay, both the pods have got two IPs. Okay, we have seen this before. Why we don't communicate to IPs? Because in Kubernetes, pods are ephemeral in nature. What do you mean by that? Like whenever pods gets restart, and wherever we restart the pod, the IP address of the pod will get changed. For example, currently this pod is having IP address 1.7, and let me delete that pod. And if I describe the pod again, you can see it is no way, like it is not having this 1.7 IP now. It is having 1.9 IP now. That is the reason we don't configure the IP address, and that's the reason why we use the services. Now let us create the service. Okay, and at high level, this is the Kubernetes service, and I have given a app equal to backend. This is the same label what I had used in the file, right? I had given while creating the deployment, the label I had given a app equal to backend, and same label I'm giving here as a selector now. Okay, and these are the port configuration, and like service will be listening on port 80, and whatever the request comes on port 80, that will be forwarded into this port 5678 of the pod. Okay, this is the pod port. This is the port where service will be listening on. And this is the important point, what we call as a type. Type is the ClusterIP service, which I am explaining now. So what is the ClusterIP service? Service which enables a communication within the cluster. So we create this service now. Get SVC. So kubectl get SVC, and you can see Kubernetes has assigned a IP address to the service. Kubernetes created a service, and Kubernetes gave one IP address to the service, and Kubernetes gave a port. Okay, and if we describe this service, let's describe this service. Okay, you can see backend service, it has this IP and listening on port 80, and whatever the request comes to this service, he will forward this to these endpoints. So pod IPs, since we have given a label selector of these pods, so you can see the IP address is 1.8 and 1.9, and that 1.8 and 1.9 and port is 5068 in comma separated way, it is attached to this service. So whatever request comes to this service, so whatever request comes to this IP on this port will be forwarded to these IPs and these ports. Okay, so for example, what we do, we go here and kubectl get svc, we do the curl, the IP address of the service and port 80 of the service. And you can see we got the hello from the backend. So this response we are getting is from our pod actually. This response is given by the pod. So what Kubernetes did here, we communicated to this IP and this port, then this service forwarded the request to one of the pods. So it works in a round robin fashion. The request may go to this pod or request may go to this pod. Yeah, this is about the Kubernetes service. And if you look into the nature of these IP addresses, right? These IP addresses are why they are like this. We are good here. Like we are able to communicate to using the service IP. We are able to communicate to our pods. But this IP is not reachable from the internet because this Kubernetes, right, creates an internal virtual network that allocates IP addresses to the service and to the pods. Okay, here if we describe the pod kubectl get pod -a, you can see some of the system pods which we have not created, but when we brought up this infrastructure, Kubernetes automatically brings up these pods. There is a pod called Calico. Okay, this pod is actually responsible for managing the IP address allocations, routing, network policies in the Kubernetes. Okay, and this network, and it also has something called as core DNS, which actually creates a, like when we communicate inside the pod to the another pod, we don't use the IP address usually, we use the name of the service, and core DNS will resolve it. Okay, and this entire network, what we are seeing, is completely different from the host machine's VM network. For example, if I do a kubectl config, nowhere I see this IP assigned, cluster IP assigned to nowhere in the interface. Okay. So this is about the ClusterIP service to enable the communication between the pods within the cluster. Now, if someone wants to connect to our pod from outside the cluster, okay, if someone wants to communicate to our cluster outside the node, for that, what we have another type of service, and that service, what we call it as a NodePort service, which we will see next. Okay, thank you. Let us now try understanding what is Kubernetes NodePort services. Okay, NodePort service in Kubernetes is a type of service that exposes an application running inside the cluster to external world, like by opening some specific port on each node in the cluster. Okay, we have already seen this diagram before, a typical architecture, typical infrastructure of Kubernetes environment. Okay, where we already know here, like we have seen an example how communication within the cluster works using ClusterIP service. Video link is in the description. Since IP of the pods are not accessible outside, since IP of service is not accessible outside the cluster, but we can make IP of node accessible outside. Okay, if you assign a elastic IP in a cloud environment or IP within your VPN where other machines in the same VPN can access, so we can use this as an advantage. And since the IP of the each worker node and node is accessible outside, so what NodePort will do, it will open one port in each node, map them into service, and then traffic will be forwarded to pod. Let's see this diagram. Assume that this is one of the worker node. What will happen, since the IP of this worker node is accessible outside the internet, when we create a NodePort, NodePort will reserve one port for this service in every node. Okay, in every worker node, it will reserve every node. You mean it's not only a worker node, every node it will reserve one port for this service, and then it will map this service against this port, and each service will have some of the ports associated for these services. So whenever a request from the external world, all these entities what I am showing here, they are outside the cluster. Whenever a request comes to this IP endpoint, the request will be forwarded to this service, and this service will forward that request to the pod. So that's how NodePort will allow an external traffic to route it to our cluster. Okay. We will see the same thing using an example itself. Okay, so in a GitHub link, I have given an example. Let's take the same example what we used to practice while learning the ClusterIP service also. Okay, first let us deploy this backend application. Okay, you can see I have created an application. I have given a label as app equal to backend. Okay, line number 15, I have given a label as app equal to backend, and the port what this pod is running on 5678. Okay, fine. So this is the backend pod. Let's create it. Now we will create a NodePort service. Okay, so here what we are doing, the port. This is the port on the node 30007. Okay, so this is this port what I am talking here. The port number is different, that is fine, but this is port what we are seeing here. What is the target port? It is the actual actual port, like port where we need port inside the pod where we need to forward the request. And what's the configuration what we are seeing here, port 80 is the port at the service. So total we needed 3 ports here. Like what happens, one the port at the node itself, that's a VM itself, then the port of the service, then port of the pod. So we don't need to create a service separately here and then attach that service to the node port. When in a single configuration, when we give all these parameters, and very important type is node port. Now if you see this time, the type of the service is a node port. So when we give this configuration, so this Kubernetes will create a node port. Kubernetes will also create a service, and Kubernetes will take care of all these mappings. So let us create that node port now. Okay, apply minus the node port. Okay, kubectl get svc. Okay, so we have got the node port created. Now to access our pod, we have pods created, right? Okay, get pod minus void. Now to access your pod, we don't need to use the IP address of the service. We can get the IP address of this VM. Let's say the IP address of the VM is, yeah, let us take this IP here. Okay. And the port what we have configured, let us take this IP, and port what we have configured is 3007. 30,007. 3007. Okay. So connection refused. Let me describe the pod. Describe the service. Yeah, I made one mistake here. Why in selector, right? I have given app is my app. Actually, it should have been backend, because if you look into the backend service, I have gave a label as app equal to backend. The same label we have to use that in a service also. That's why it is not able to point to the proper pod. So what I will do, I will change this name to backend. Okay. Then I will replace it. A replace minus f node port. Okay. Now should have been fine. Now let me do a curl. You can see I got the response. To whom I am communicating? I am actually communicating to the IP address of the node itself. This is the node. I gave the if config, got the IP address of this node, and now when I do the curl, what is happening? It is actually forwarding this request to a service, backend service, and that service is forwarding that request to application. Okay, so that's how the NodePort service will work. Now we see further concepts where like sometimes we don't allow this node itself directly to be exposed to the public. Sometimes we bring up one more like middleman, what we call that as a ingress. Sometimes we call, there are another alternative called as load balancer. We will talk about that in our coming section. Let us now briefly see what is load balancer service. Okay, so load balancer service is a service provided by cloud provider that distributes an incoming traffic from internet to backend application. Okay, so there are several load balancer available over the internet. AWS provides Elastic Load Balancer, Google provides Google Cloud Load Balancer, Azure provides Azure Load Balancer, and DigitalOcean provides DigitalOcean Load Balancer. How the typical infrastructure look like? So we have already seen how within cluster communication works. We just need a service and pods, and to provide a traffic from the outside of the cluster, we need this infrastructure where we will have a pod service and we will have a NodePort service also along with. Okay, so now to provide the sometime we don't most of the time in production it happens we don't really expose the IP addresses of our node for external communication. So for that reason, what we do usually, we will create a something called as load balancer at the internet itself. Okay, so what happens while creating the Kubernetes cluster, we provide the cloud details, example credentials, configuration, etc. When we define a load balancer service, Kubernetes communicates with cloud providers APIs to provision a load balancer for us. Okay, and it automatically configures the load balancer to route the external traffic to the appropriate application endpoints running in our cluster. Okay, and as of now, I don't have a setup to explain. I need to get one setup in the cloud. So once I get that setup, I will practically explain you how we choose the load balancer and how we communicate it to communicate our application using load balancer. What is external service name? Okay, external service name is one of the optional feature, like it is optional to use actually. It's a feature in Kubernetes where you can map service within the cluster to an external DNS name. Some external DNS name, you can give a name which looks like a service name, allowing application to access external resources like APIs, database, as if they were local service. If you look into this example, let's say you have created a database in cloud, okay, and you want to configure that database in your application. Okay, let's say the way the website to access that database is mydatabase.aws.com. Okay, so what you can do, either you can give this name inside your application, then you don't need to create an external name service. And sometime what you can do is you can create a service, okay, and type, you can give external name. Okay, when you give this type of service, then inside your application you don't need to configure this URL. Okay, rather than inside your application you can use this service name. So one thing is application always interact with services using Kubernetes naming convention. Okay, this is the one of the advantage why we use the external name. And one more advantage is, let's say today you are using a database from AWS. Let's say tomorrow you want to use it from cloud, then you can give, you don't need to modify your application. Okay, because application is always using this service name. Okay, you can come to this service, you can edit this name, you can edit the service, then application will start using different external name. So this is what brief about external name service. This is the last session of Kubernetes service chapter. Let us now understand what is headless service. Okay, headless service in Kubernetes is a special type of service that does not have cluster IP itself. Okay, and does not even perform the load balancing among the pods. Okay, instead it will allow you to directly access the individual pods of the services. Okay, let us now try understand this with an example. We will come to the killer coda. We will go to the killer coda, and we will refer the same example what we had learned during the stateful set chapter. So in this example, we can see we have a pod. Okay, we have a stateful set named nginx, and we have given a label to the pod as app nginx here, app nginx at line number 14, and 3 replicas we are creating. And one of the important parameters is here service name. Okay, when we specify a service name in stateful set creates a DNS entry in core DNS plugin, which manages the Kubernetes internal naming resolution. Since the name of the pods are fixed, since the name of the service is fixed, so it is easy for a stateful set application to add that entry in advance itself, even before creating the service. Okay, so let us create this stateful set. Apply minus sts.yaml. So you can see our pods are coming up here. Okay, so you can see three NGINX pods are running: NGINX 0, NGINX 1, and NGINX 2. Now what we will do, we will create a headless service now. So here I have given an example of headless service, and better what I will do, I will better take the ClusterIP service itself, and I will convert this into headless service so that you will understand it better. Okay, so svc.yaml. I have already this file. Okay, so I will use svc2.yaml. Okay, what all we need to change is one app selector in stateful set application. It was app NGINX, so give the same name here. Okay, second thing, target port. Target port here is 80 in stateful set. I will let you open the stateful set once again for you to confirm. The target port here was 80. Okay, now in the service, important parameter is the name of the service. We have already seen in the stateful set, we have given a service name parameter as the NGINX. We need to give that name here. Okay, and now very important parameter is NGINX. A very important parameter is here a type. Okay, so when we want to create a headless service, we actually don't give a type itself. Okay, we remove this type. Okay, and there is a new parameter called ClusterIP. Okay, and what we give ClusterIP as null. Okay, this is the typical configurations to create the headless service. Let's create this. We apply minus SPC, right? svc2.yaml file. Service is getting created. Get SPC. So we have a new service created called NGINX, special NGINX, and we can see here we don't have any cluster IP assigned to this service. Since we don't have a cluster IP itself on for this NGINX service, you might have already understood that there is no way to access this service using a cluster IP. Okay, what we see in cluster IP service example, where we used to access the pod using the cluster IP and it used to perform the load balancing. We don't have a cluster IP itself here. So so now in this case, how do we reach to the pod? With this syntax. What we do, pod name dot service name dot namespace svc cluster dot local. Okay, what we do to demonstrate this, we will take one more example. We will take one more stateful set, like any pod we will create. Let's say front end deployment I will create. Okay, VIM front end deployment.yaml. Okay, we will create one sample pod to just to demonstrate this. How do we reach to the pod using headless service? fd.yaml. So we have a pod created. I will go inside this pod. Get pod minus w. A pod is ready. exec pod name I will give. So I'm inside this pod. Now, let us form a name of this service now. Kubernetes kubectl get svc. The syntax is this. Since this is the syntax, okay. This is the syntax. Pod name. First, we will have a pod name. Get kubectl get pod. Yeah, let us. How do we form the name of the service? We will try to ping from this pod. The syntax is first pod name, then service name. NGINX is our service name. Then namespace. Currently, I have created all the pods in the default namespace. Then we have the common syntax like svc dot cluster dot local. Okay. When I ping to this server, you can see I'm directly able to reach to the pod. Okay, and if I want to reach to the pod 1, I can, like it was 1.10, 1.11. Okay, kubectl get pod minus oy. You can see 1.11, 1.12, 1.10. All these IPs we were able to reach from a different pod directly using the pod address. This we can call as the address of the pod, because we are here. There is no load balancing. Okay, so that is what about the headless service. So with this we end the series of Kubernetes services. Thank you for watching. Definitely like, subscribe, and if you have any doubt, put that in a comment section. Thank you.